Have you ever stopped and wondered what's actually going on inside the so-called mind of an AI? Well, today we're going to pull back that curtain. We're diving deep into AI agents, and you're about to see that not all AI is created equal. Each one thinks in a totally different way.
So that really gets us to the heart of it, doesn't it? When we talk about an AI making a decision, what is actually happening under the hood? How does it look at the world around it and decide what to do next?
Well, it turns out the secret is all in the design. An AI's thinking process is completely shaped by its architecture. So we're going to go on a little journey, starting with the most basic AI minds and leveling up step by step to the most complex.
Here's our game plan. We'll kick things off with the purely reactive agents, the simplest ones out there. Then we'll see what happens when agents can actually plan for the future. After that, we'll explore the really cool stuff, agents that learn and even team up. And of course, we'll wrap it all up by answering that big question: how do you pick the right agent for the job?
Okay, first up, let's talk about the absolute foundation of AI decision-making, the reactive agents. You can think of these as the fundamental building blocks, designed to do one thing really well: respond to what's happening right here, right now. So, at the very bottom of the evolutionary ladder, we have the simple reflex agent. This thing is pure instinct. It runs on a super simple if this, then that kind of logic. There's no memory, no looking back, just immediate reaction. It's incredibly fast for simple tasks, kind of like a traffic light that's just running on a basic timer.
But, there's a huge catch. What happens if the agent can't see the whole picture? With zero memory, it's like trying to navigate a maze while you're blindfolded. You're probably just going to get stuck, right?
And this is where we see our first big upgrade. Take a look at the left side here. That's our poor, memoryless, simple reflex agent. Completely lost if it can't see everything. But now, look to the right. The model-based reflex agent has a kind of superpower, an internal memory, or what we call a model of the world.
This internal model is a game changer. It lets the agent keep track of stuff it can't currently see. The perfect example is one of those robot vacuums. It's not just bumping around randomly, it's building a mental map of your room, so it knows where it's already been and where that pesky table leg is, even when it's on the other side of the room. This makes its decisions way more informed.
Okay, so we've given our AI a memory. That's a huge step. But what's the next level? Well, let's take a giant leap from just reacting to the present to actually planning for the future.
And that brings us to the goal-based agent. Instead of just reacting, this agent is proactive. It has a specific goal in mind, and it uses planning algorithms to figure out the best possible sequence of actions to get there. It thinks ahead.
The process is pretty straightforward. First, you define the goal, say, deliver a package. Then, the agent plans out the whole sequence of actions, the best route to take, and finally, it executes that plan. A logistics AI planning the most efficient delivery route for a truck is a perfect, real-world example of this in action.
But what if just reaching the goal isn't the whole story? What if you have to balance a bunch of different factors, where how you get to the finish line is just as important as actually getting there?
That is where the utility-based agent shines. This agent is the master of the trade-off. It doesn't just find a path to a goal. It finds the best path by weighing all the different factors to maximize what we call utility, which is really just a fancy way of saying the best, most desirable outcome overall.
So at its core, this agent has a utility function. You can think of it like an internal decision maker that's constantly weighing the pros and cons. Should it be faster or cheaper? Should it take on more risk for a bigger reward? A financial portfolio agent is the classic example here. It's not just about making money, it's about finding that perfect, delicate balance between risk and return that's right for a specific person.
So far, all our agents have been following rules that we gave them. But what if they could learn and get better on their own? Well, welcome to the top of the pyramid. Agents that can learn, adapt, and even team up to solve absolutely massive problems.
So, meet the learning agent. The key feature here is that it's not static. It has one part that goes out and acts in the world and another part that takes feedback from those actions to get smarter over time. A customer service chatbot is a great example. It literally learns from thousands of conversations to get more and more helpful.
Now, as you can see here, there are two main ways these agents learn. On the left, you've got supervised learning. This is like giving the AI a textbook with all the correct answers in the back so it can study. On the right, you have reinforcement learning. This is more like learning to play a new video game. You learn by doing, through trial and error, getting points for good moves and losing points for bad ones.
But hey, even the smartest AI can't do everything by itself.
So what happens when a problem is just too big, too complex for one agent to handle? Well, you build a team.
One way to do that is with a hierarchical agent. This approach breaks down a huge task into different layers, kind of like a chain of command in a company. Let's use a drone delivery system as our example. At the very top, the strategic layer is like the CEO, managing the entire fleet. The middle tactical layer is like a manager, assigning a specific delivery to one drone. And down at the bottom, the operational layer handles the nitty-gritty details of that single drone's flight path.
Another approach is a multi-agent system, or MAS for short. In this setup, you have a bunch of autonomous agents all interacting with each other, but with no central boss telling them what to do. They negotiate, they cooperate, sometimes they even compete to solve problems. Imagine a smart traffic grid where the cars and the traffic lights are all talking directly to each other to figure out the best way to keep traffic flowing. It's totally decentralized.
Okay, we have covered a lot of ground, from simple reflexes all the way to complex learning teams. So now we get to the most important part. How do you actually put all this knowledge to work? How do you pick the right tool for the job?
This chart right here is your ultimate cheat sheet. It lays out the key strengths and weaknesses of every agent we've talked about. You can see the super fast reaction time of the simple reflex agent, but also its major limitation, no memory. You see the future planning power of the goal-based agent and the careful balancing act of the utility-based one. But it also shows you the downsides, right? Like how a model-based agent can be computationally expensive, or how a learning agent is always hungry for more data.
So, let's make this really practical. If you have a stable, predictable environment, a simple reflex agent is probably your best bet. If you're working with incomplete information, when the environment is partially hidden, go with a model-based agent. Need to plan several steps ahead? That's a job for a goal-based agent. Juggling a bunch of complex trade-offs? You absolutely need a utility-based agent. If your environment is constantly changing, a learning agent is a must. And for those massive, coordinated operations, a hierarchical system is really the only way to fly.
So we've traced this incredible journey from the simplest AI reflexes all the way up to complex learning and collaboration. We've really seen a clear evolution of intelligence. So I'll leave you with this final thought to chew on. As all these specialized agents start to work together in more and more complex ways, what new forms of collective intelligence are we about to see emerge?